Basics of music. In this course, we're going to teach you everything you need to know to be a musician. We're going to be covering a lot in this episode. I'm going to be skipping over some of the details because my point is just to give you a basic overview of what you need to know. So starting from the beginning, music is frequencies, vibrations per second. This note vibrates 440 times per second. That means in every second, we hear a vibration 440 times. Now, I know that doesn't sound right because you can't actually hear each individual vibrations, but remember, they're going so fast that what you're actually hearing is the note. So what does it sound like when I slow or speed up the vibrations? So in order to demonstrate frequencies, I'm going to tune my mandolin. And what you're going to be listening for is when two tones match perfectly. And what you're actually hearing is when the waves are exactly the same. And when they're not exactly the same, you're going to hear it. So here is my A440 on the keyboard, and I'm going to bring this string to match it. The moment when this string matched the keyboard pitch, the two sounds became one. To further demonstrate this point, on the mandolin, I have double strings. These strings should sound exactly the same. Listen as I bring the bottom string to vibrate at 440 times per second to meet the top string. Now I'm going to make the string sharper and bring it back down so you can hear it again. Did you hear it? When the sound almost becomes clean, you're actually listening to math. And when the vibrations match, they're in tune. So here's a little thought experiment for you. If a saw is cutting a piece of wood and it vibrates 440 times per second, is it playing a note? Well, technically, yes. Anything, whether it's a wood saw or a violin or even a vacuum cleaner, can create pitch. And that pitch is solely defined on the vibrations per second. So all I want you to take away from this first part is that every note that you hear in music is a vibrations per second or a frequency. What is the harmonic series? The harmonic series is a natural framework upon which music is built. Originally credited to the myths of Pythagoras, the harmonic series was discovered and is the basis for all of Western music. Where do these notes come from? Well, that's a whole nother source for debate. So all we want to point out in this video is that the harmonic series exists, what it is, and how we use it. The trombone is one of the simplest instruments we have, and it is based on the harmonic series. When I blow in the mouthpiece here, the air travels through this tube, which is a finite set length. Unless I move the slide, the instrument does not get longer or shorter. In this chart, you could see the first couple notes of the trombone's harmonic series. Now, if you notice, there is space in between the notes I played, but I can't play them on the trombone. Listen as I try to play any other note other than those four without moving the slide. It's not possible. So even though I tried to get the notes in between, notice how the trombone stops working until I can play the notes of the overtone series. This is to prove to you that the overtone series exists and how it works. Notes outside of the harmonic series cannot be played. And based on this natural limit, the limit to only the notes in a harmonic series, we base our whole system of Western music. So far, we've learned frequencies are vibrations per second, and those create what we call notes or pitches, such as 440 vibrations per second. Next, we've learned the harmonic series is a natural framework that emanates from any note played. The third part of today's lesson is the octave. In the harmonic series, the first building block is the octave, and an octave is the same pitch class, but a different frequency. So let's break that down. On the piano, I only have 7 notes, but 88 keys. So obviously, the pattern repeats. That means I have more than one A. Getting back to our original A440, if I want an A an octave lower, I'm going to play 220 vibrations per second. And if you notice, 220 is exactly half of 440. Vice versa, if I want to play the A higher than 440, learning that if I halved it, I go down, I'm going to double it to go up. So if I have something that vibrates at 440 times per second, and I want the octave up, I need to vibrate 880 times per second. So we've learned that the octave is doubling or halving any frequency. If I have A220 and I half the frequency to 110, I'm getting a lower A. And if I have A220 and I double the frequency, I'm going to get a higher A at 440. So now that we have the octave, what do we do with the space in between? Well, we're going to get there in a few lessons, but next, we're going to show you how to write music so it's a little easier to explain this with a visual component. Recapping for lesson 1, we've learned that frequencies create all the pitches that we hear, and they are vibrations per second. Anything that vibrates 440 times per second is an A. The next thing we learned is the harmonic series, a natural framework upon which the Western music scale was built. And finally, the octave, which is the first building block of the harmonic series. With all of these tools, we're going to teach you how to write music next, and then we're going to come in and start filling in the blanks. If you enjoy the West Hollywood Youth Orchestra's Basic Music Series, please subscribe below and visit us at YTOoA.org for accompanying lesson plans and more.